We are finally going to slay the dragon named minimum window substring. Let's get started. Minimum window substring is a hard problem on lead code. It is notoriously difficult to understand for the first time. If you've seen all of this week's content, it should actually be astonishingly easy for you to understand. Let's get started with it. The problem statement goes something like this. Given a string s and t, find the minimum window in S, which will contain all the characters in t in time complexity of O of n. We'll come back to the time complexity later. Essentially what we'll have to find is, we don't have to search for t in S. We have to find a small segment in S such that it contains all the letters required to recreate t. That is basically our problem here. In this example, t will be ABC. We'll have to find a segment in S such that we can use some of its letters to recreate t. And while doing so, we'll have to find the smallest segment. Obviously, you can take the entire of the string S as one segment and then try to recreate ABC from it. But that won't be the smallest. So, among the visible options on screen and the others, the smallest will be given to B, A and C. It is the smallest segment of size 4 and you can recreate ABC from it. Okay, I see the problem, but how am I going to solve it? Using the power of sliding window technique. Since this is a sliding window technique, we'll be using the two pointers L and R to demarcate the left and right boundaries of the window. We'll also be needing a needed hash map. I'll tell you why it is needed in the future. We'll also need a minimum variable min start and min length because we'll have to return the substring as the result for this problem. The test condition goes something like this. The number of occurrences of each character in t should be less than or equal to the number of characters in the current window. It is a nerdy way of saying we'll be using the characters within the window to recreate t. So the characters in the window should be exactly equal or it can be more than what is required. Hence we'll be needing the needed hash map to store what is needed within the window. The test condition's visual representation is something like this. ADOBEC is the current window under consideration. We'll have to recreate ABC from it. Now if you notice, you have exactly enough number of A, B and C. There can be more also, but as far as we are concerned, there should be 1A, 1B and 1C in the current window. Hence this is a valid window. Also do recollect that we'll be expanding while the window is valid and contracting while the window is invalid. That is why this test condition is important. Now Akash will take over and do a dry run of this algorithm on an example. On a side note, this is one of those rare moments when Akash touches something that is not wet.
So now let's look at an example for our problem. So what we have over here is our string S and here we have our string T. So what we need to find is a substring in S which contains all characters in string T, and this substring has to be of minimum length among all valid substrings. So we initialize our left and right pointers to point at index 0. We initialize our min start variable to be 0 and our min length variable to be equal to max, and we initialize our counter variable to be equal to 3. So the reason we make use of a counter variable is because it denotes the number of characters that are still required for our substring to become a valid substring, and the reason it is initialized to 3 or the size of string T is because any substring in S, if it has to be a valid substring, it should have a minimum length which is equal to size of string T. So, and we also initialize our hash map with characters and their occurrences of characters present in string T. So this is our initialization process. Min length variable is initialized to int max, so or the maximum possible value. Now let's look at the dry run. So first our R pointer points to A. So A belongs to our string T and the value of A in our hash map was 1. So we decrement the value of A in our hash map and now it becomes 0. So whenever we decrement a value in our hash map and it becomes 0 or is still a positive number, we need to decrement our counter variable because we have now included a character in our substring which was also a character in our t. Now we move our R pointer towards the right again. It points to D. D does not belong to our substring T, our string T, so therefore it does not bother us. So we just ignore it and move on to the next character. Similarly, O does not belong to T, so we just ignore it, move on to the next character. Now R points to B. At this point, we decrement the value of B in our hash map and it becomes 0. And since the value of B in our hash map was a positive value, we need to decrement our counter variable because we are now included a character into a substring which was previously not there. So now our counter variable becomes 1 because we still need to find 1c for the substring to be valid. So we move our R pointer towards the right. It points to E. E does not belong to T, so we ignore it. Now our R pointer points to C. So we decrement the value of C in our hash map. It becomes 0. And since it was a positive value, we decrement the value of counter. At this point, we have counter is equal to 0, which means we have a valid substring on our hands. So we make a note of this valid substring. So the min start now becomes 0 and the min length becomes r minus l minus 1, which is 6. So it replaces the previous int max which was there as min length. Now our min length is 6. Now we try to shorten the substring and check if we can find a smaller substring which is still valid. So to do that, we move our L pointer towards the right. Now when we move our L pointer towards the right, what happened is we removed an A from our window, but A is a part of our string T. So we increase the value of A in our hash map and now it becomes 1. And since it has now become a positive value again, we will have to increment our counter variable. So at this point, our counter variable now becomes 1 and it is no longer 0, which means this is no longer a valid substring. So we'll have to move our R pointer towards the right again to find a valid substring if it exists. So our R pointer points to 0. It does not belong to T, so we ignore it and move. Now our R pointer points to D. Similarly, ignore it and move. Points to E, ignore. Now it points to B. So at this point, we already have one B. Now we are including another B. So this is just an extra B that is being added. So our value of B in our hash map becomes -1. So since it is a negative value, we do not decrement our counter variable because a negative value in our hash map basically indicates an extra character that is being added to a substring which is not required for us to have a valid substring. So we do not decrement our counter still remains 1 because we still need to find that 1A. So we still need to continue moving our R pointer towards the right. We move our R pointer towards the right. Now we have found an A. At this point, our value of A in our hash map becomes 0. Since it was a positive value before becoming 0, we also decrement our counter variable. Now our counter variable is 0. This means we again have a valid substring on our hands. So we try to compare its length with the minimum length that we have. So clearly this substring is larger than the minimum length that we have. So we try to find a smaller substring. And to do that, we move our L pointer towards the right. It points to O. We removed a D and now it points to O. We are going to remove O and it will still be a valid substring because O does not belong to D. Now it points to B, and when we remove this B, what happens is the value in the hash map will now become a 0. Since 0 is not a positive value, that means this B was just an extra B, which it is. So therefore we do not need to increment our counter variable because even after removing this B, our window will still be valid. Now this is our window. We have our B as 0 here. Now we remove our E because it does not matter to us since it does not belong to T. Now our L points to C. So when we remove the C, what happens is we will have the value of C in our hash map to be 1. Therefore, we will have to increment our counter variable. At this point, if you see, the substring length is also 6, but we already have a substring length 6, so we don't take the substring into account. We just ignore it since it is just equal to whatever we have already. So we just move on. Now we increment our L pointer and we have removed our C. Counter becomes 1. So our substring becomes invalid. So we'll have to move our R pointer towards the right again. We move our R pointer towards the right. It points to an N. It does not matter to us. So we need to move our R pointer towards the right again. Now it points to a C. So our counter becomes 0 because the count of C in the hash map was a positive value. So we have a valid substring again, and we check if this substring length is smaller than the substring that we already have. It is not because this is 7 and we have a substring of length 6. So we try to find a smaller substring again by moving our L pointer towards the right. We move the L pointer towards the right. We got rid of an O. Now it points to D. And after removing D, our substring will still be valid because D does not belong to T. Now L points to E. At this point, what we have is a smaller substring. So it starts at index 8 and has a length of 5. So we update our min length and min start values over here. Our substring is still valid. Now we remove this E. Our substring is still valid and now has a smaller size than what it had before. So our min length is now 4 and min start is now 9. Now our L points to B. So when we remove this B from our window, what happens is the count of B in our hash map now becomes a positive value. So in that case, we'll have to increment our counter to 1. So our substring stops being valid and we can't move our R pointer further to the right because it would exceed the length of string S. So we have exhausted all our possibilities and this would be our final answer, B, A and C. This is the minimum length substring which has all characters in T from S.
I hope you built an intuition of what is what. Shyam Suresh does all these hard problems. Up next, he'll code it on lead code and then solve a similar question, which is beer and steady gene on HackerRank. Stay tuned for our next video to watch it. Thank you so much. This has been BreVITy. Bye.